hearing me? Yes. Yeah, so let's go. I'm super excited as the last couple dozen of people. So my talk here today is about vaccination, an anti-honeypot approach. I'm not against honeypots, I'm just pro doing the opposite of honeypots. Just like that, the opposite of honeypots, yeah. Well, let's first do a quick recap of what are honeypots. Oh, no, first, who am I? Yeah, that's also important. Hi, my name is Gal. I'm a researcher from a small startup called Minerva Labs. I actually do there the same stuff that I'm doing here in this quick demo. But let's cut all of those promotional stuff. I'm a big fan since I was a little child of breaking stuff and putting them back together again. My guitar amp, my guitar itself, my PlayStation, my CD-ROM, some were put together back again, some weren't. My parents, I think, don't know about all of them until today. I got expertise in calling expert when I can't break it, put the stuff back together after I break it. So at least I'm learning stuff since I was a child. I'm fluent in a lot of weird languages like Java, C#, Arabic, Python. Yeah, I know that the C# one was really surprising. Yeah, yeah. Ahla wa sahla fikum. Okay, so if you want, oh, you can see it. It's my Twitter account. Just search gal_B1T. It's bit from Bitensky. So, the honeypots. What is a honeypot? Most of you already know, I guess, but a honeypot is basically that lady in red. Here, the lady in red is Xenia Unatop from the Bond movie GoldenEye. Maybe you're familiar with the two satellites in those movies, Petya and Misha. Both are ransomware that were kind of a thing lately. And this is Sean Connery, of course. And she's the honeypot. She's that lady in red that is first to appear in each Bond movie. He tries to lure him. He thinks, as the misogynistic scumbag that he is, he thinks that she's a great catch. She's doing this little dance, and then he comes right over, and, well, most time he understands that it's a trap. That's another movie. And she's ain't no bargain, so he just, yeah, gets rid of her. Not all of the honeypots are this lousy. There are some good honeypots, but this is a very, very common case. So, this is the what-if moment. What if instead of attracting the bad, Bond is a metaphor for the bad guys. So, he's a bad guy. What if instead of attracting the bad guys to us, what if instead of doing so, we'll repel them? It's quite of the anti-honeypot stuff I was beginning with. So let's begin with an example from nature, as repelling the predators or attackers or hackers is just a natural thing. On the right side of the screen, you can see this snake. It is a very, very venomous snake. It is called the Texan coral snake. But can you spot the difference between this one and that one? This one is a Mexican milk snake. Yeah, I've actually learned biology for this. It is non-venomous, non-poisonous, no nothing, but as predators don't want to eat this one, they don't want this one as well, because they're not really similar, but they just won't take any chances because they're quite similar. And well, you don't want to get mixed with one of the deadliest snakes in North America and some milk snake. So there's even greater example here. Yeah. Here you have two butterflies. They look exactly the same to me, but I'm not a biologist, so maybe it's just me. This is the monarch butterfly, and this is the viceroy butterfly. This one is poisonous if a bird will eat it. It won't, I don't know if it will die, but it will have some digestion issues. And I guess it's not that good if you're a bird. And yeah. They usually do their stuff all over me. I have this kind of, I think it's called luck. Yeah, I don't know why. So, again, the one on the left side is non-poisonous, non-venomous. I don't know any venomous butterflies, but if there were any, it's not this fella here. But again, birds won't eat it because they think it's poisonous. The bond character won't be attracted to it. It will run the other way. So, let's do a quick recap again. We've seen honeypots. We've seen the basic motivation behind anti-honeypots, you know, like repelling bad guys. But what are the analog of this poison venom for bad guys? I think that hackers, or hackers, as I like to call them, they don't care much about butterflies. I have about roughly 4 categories of stuff that bad guys are afraid of. First one is you guys in the crowd. They're afraid of analysis and all kind of maybe automated analysis, maybe manual analysis. They don't want to be analyzed. The more they're out there without being analyzed, the more money they'll do if they're ransomware, the more stealth they gain. If you're an APT, you're a state-sponsored campaign, you don't want to get caught. We'll go to it later, but in the live demo. But you all remember Hacking Team. Their first scout actually checked for virtualized environments in Wireshark, I think, and a couple of other stuff. They actually try to mislead the reverser directly by, you know, checking is debugger present, do you have a process monitor window open. I personally find it insulting because if I'm debugging you, I see that you're calling is debugger present. I can, you know, change the answer, but yeah, what the hell. They also try to fool automated analysis. This is quite more interesting because if you have a setup of a couple dozen of sandboxes, I think it's much more realistic to try and fool this massive, you know, setup that you have. But that's for pros. They're often seeking for static and dynamic analysis tools, like I mentioned, and all sort of virtualization infrastructure, as commonly those tools, you know, you are analyzing the machine, commonly not on physical machines, analyzing the malware, sorry. So, this is an example from, it's quite old, it's from 2007, from Leket USA. It's an example of how you can do it. It's just calling the FindWindow API. That's simple. It checks for both OLEDBG and WinDBG. You can read the documentation of FindWindow. The nice thing about it, it just doesn't change. You know, people are still using OLEDBG and WinDBG, and if they want to check for those debuggers, they can still use those functions, and we will abuse them later. So, let's go to the second fear. Oh, no. Another example first. This is actually kind of a fresh thing that I've analyzed a couple weeks ago, maybe a month ago. It's from a fresh sample that I was able to get. I was first quite suspicious as I saw it's calling the, I don't know if you can see it, it's the get username A Windows API. And if it, I saw it not here, but in the IDA output, that if it finds specific unknown stuff, maybe it can exit. So I looked further into it, and I saw this kind of ugly binary with all sort of jumps. Those ASCII ninjas out there in the crowd, please be silent, don't spoil the surprise. Well, I'm not an ASCII ninja, so I just took all of those values here and saw that it just moved character by character, and if it finds all of those as a match to the thing pre-coded in, it will exit when surprise, what is string, sandbox. So it's a nice thing. It's afraid of machines with a user named sandbox. Surprise. Yeah, now to the second fear. The second fear is also you guys in the crowd, once again. But this time, your products, not you directly. They're afraid of high fences. If they see a high fence, they can actually use the attacker's advantage here. They can assess, can we jump this fence? Can we, I don't know, maybe walk around? Maybe we don't want to jump this fence this day. We're afraid to get caught. It's a classical case of the attacker's advantage. Maybe I can bypass 90% of the fences in the world, but if I see a specific fence, I know that this one, no. I just walk home and wait for another day. We actually will see a case of this in live demo, where a sample seeks for 3 vendors of antivirus. I think it's checking for ESET, Avast, and Kaspersky. And if it finds any of those 3 vendors, it will simply terminate. It knows that in this specific time, only these 3 vendors are detecting I think it was a Loki ransomware. So why would I want to? I won't encrypt this machine because they're catching me, and I don't want to get caught and submitted, and all my CNC infrastructure will get caught, and why? Okay. That's the mandatory slide with the cat in the presentation. Their third fear is from themselves. They don't want to infect the same machine twice, so they often do some weird kind of, I'm not calling it mutexes because they don't know often how to code this kind of stuff, but they have some kind of infection markers and other mechanisms they use. And sometimes they even use proper software engineering, and they do use mutex in a proper way without inventing any kind of a new way of executing a program safely, because malware is a software. So you do want it to be a working, functional program. So in both cases, we can abuse them. We can tell them, well, you're already running on this machine. How in the next section? But before the next section, there's another kind of fear they have. Again, surprising one. Oh, again, I forgot. There are a couple of examples first. This is actually kind of a common worm. It's the Conficker worm from back in 2009. You can see how it checks up there for again, the screen is not great, but trust me, it checks for the mutex, and it stores it in this. It gets the last error here. It checks it only here, but trust me, this hex value is the one if it is already created, and it will simply terminate. This is actually, I think it was a catastrophe back then, and I've heard many stories about people running and doing actually vaccination back in 2009, running with CDs all across their organization and vaccinating their organization against this kind of malware. I think it was probably one of the first vaccinations, even before they invented the term vaccination. And here's another more recent example. This, as the latest one, was taken from this guy's, that I can't pronounce his name, website. Okay, he said his last name. Yeah. So this is actually one of the first Loki samples to appear. They did proper software engineering. They opened the registry key under HKLM software Loki, with the name Loki. And I think that they had a value called completed, and it had a binary value data. It could have been true or false, and if it was true, it will simply skip the encryption phase, and it is kind of a proper software engineering. They used the registry. Even they were nice enough to put themselves in the software, under the software registry key. Well, we can abuse it, as you can guess, by simply creating this value. Next. Now, the last surprising fear. Yeah, Russian. Why? This is a great example why we should not vaccinate without, just let's vaccinate, let's protect ourselves, let's create everything we can. There's no kind of trouble that can be caused by it. Actually, it's quite funny because if you have a Russian keyboard on your machine, some malware will avoid you. Maybe it's because of this fella, and I'm talking about this fluffy little fella, of course. Yeah, he's so cute. Maybe they're afraid of him. Well, you can only guess why they won't infect Russian citizens or people with Russian keyboard, but it's quite surprising, but other malware is actually, I call it comrade-targeted attack. Yeah. It will infect only guys with Russian keyboard. So adding a Russian keyboard will save you some of the malware, but you'll get infected by others, so I don't recommend this kind of vaccination. I don't think it's good. By the way, I only can guess again why they're targeting Russian guys. Maybe they have better access to their, infrastructure to exfiltrate money out of their bank accounts later in the phases of the attack. I don't know. Again, guesses. Okay, so till now we've seen honeypots, anti-honeypots. The anti-honeypots, the real fear is how we can actually repel guys, but we haven't seen actually how we can repel them because we've seen what are only the equivalents of poison and venom. We didn't see, you can't just color your computer in red and black and white or paint those, maybe give the computer a suit of a butterfly. It won't work. So how we can disguise our machine as the poisonous butterfly or the venomous snake? This will be this session. So first, there's a class of static Windows artifacts, like registry keys and values, files and folders. I like this class because it's really easy to create it. I can just execute a Python script. For example, this one. Don't worry, I'll upload everything to GitHub. You'll see the URL later on. It's so simple. I can just create a file in program files, VMware, or ESET, or any kind of other thing you can imagine, and it will be there forever or till I delete it, and the malware will be afraid of it. It will think that there are analysis tools, and yeah, I win. So the next class I like a little bit less. It's like dynamic artifacts. Those are stuff that I can create, but I need to recreate them over and over again, like processes, mutexes, windows, as we've seen with the OLEDBG. I think that there are, different approaches to do it. You can run 1,000 processes, then name them Wireshark and, MS Paint. No, malware is not afraid of MS Paint. But it's not scalable. It's not. You can do it, but I don't think that your computer will like it, and you as well when you will try to kill real processes that you want to kill. And my task manager is like this size. So there are more clever approaches to this, but this is beyond the scope of this specific lecture. So if you really want, you can talk with me later on. And I'll just show it to you. There's the last class of those. We had the static, the dynamic, and this class is really different. This class is kind of a low level. It's not exactly artifacts. I call it artifacts. Each thing that you can detect that the machine is hostile for the malware is for me an artifact. It's kind of traces that virtualization. It's most often virtualization leaves on your machine. The most famous one is this one, the red pill. It looks simple. It's not. I guess it took a year or more to detect it. It was detected by the Polish researcher Joanna. Again, I can't pronounce those crazy last names. I have one as well for me, but hopefully someone will struggle in pronouncing my name in 10 years from now. This one is actually very, very nice thing. It is searching this, it's actually a mask. It seeks for specific place in memory where the interrupt descriptor table is. It turns out that in specific machines, it is located in specific virtual machines. As a result of the virtualization, it's located on one place, and other machines it's located on other places, and you can actually detect not only that you are in a virtual machine or not, you can even detect the vendor of the virtual machine by just looking in the memory and using this mask. So, real nice. There are also many other kind of techniques. You have timing attacks. There are some instructions that are sensitive to virtualization. You have other features, like calling for a CPU low-level state APIs, and there's a bit that is on if you're on a virtual CPU, also stuff like this. It's much more difficult to mimic. I can't just execute a Python script. At least, I can import CPU, and I guess that there is a kind of a Python library for this, but I guess that it's not really simple behind this library. But why the hell should I bother and do it? Because there's a great example for it, actually. Those little fellows here, those are the copy kittens. They're an Iranian gang I researched with our fellows in a company called Clear Sky about a year ago. They successfully, I guess, hacked the Israeli Ministry of Foreign Affairs. In their malware, they had about 70 different types of functions that tried to check all kind of artifacts. About 20 of them were related to this low-level CPU stuff, but the other 50 were all simulated by a couple of simple Python scripts. And bam, we prevented Iranian APT. That simple. And of course, they have the logical OR between all the terms. That's the secret. So let's have some fun. I hope you can see this one. This is MC Hammer from Hammer Time. Yeah, that's a joke. Can you see this URL down below? This is the repository. Let's go to the demo quickly. What I've had in mind here, I prepared a machine with 4 different viruses. I think that we'll have time for all of them. Yeah, we'll have time. I'm going to execute them. Yeah. And the hashes are also available online, so you'll be able to test them at home too. Yeah, I've added this magnifying glass, but I'm not sure that we'll need it. You can see this small font here from the back rows. So yeah, let's close it and maybe I can just duplicate. So it will be much more easy. So. And duplicate the display and duplicate it. Yeah, much easier now. So let's close this magnifying aid. Okay, so first I have this little nice tool called Pafish. Pafish the Paranoid Fish is actually a tool by a guy named Alberto Ortiga. He's Spanish, so I can pronounce his name, simple last name. It is a tool for, actually it was created for your use to check if your sandboxes are immune to evasive sandbox. I'll just execute it as we speak, so we'll be able to see. It's basically checking for about 27 or 8 different ways to detect virtualization. You can see it prints. If it finds any kind of stuff, it just print traced. This machine is kind of stealth. It's not fully stealth, but you can see that, for example, I didn't hide my all kind of hardware stuff, the CPU ID bits and hypervisor bit, whatever. But those stuff over here, which are, I'll put it a bit more on the upper side of the screen. You can see that the VirtualBox related artifacts, for example, here are clean over there. I don't have any kind of virtualization traces in this matter. We'll first execute a couple of samples and without the vaccination. Then we'll execute this short Python script. It takes less than a second, and we'll see how it changes the way malware acts. So let's begin with something which is quite recent. Let's open Process Explorer and Process Monitor. Don't worry, I prepared filters in advance so it won't spam. IronGate is a nice thing. FireEye researchers detected about 3 weeks ago, I think. They called it a kind of a Stuxnet, as it targeted industrial control systems. It actually had quite similar behavior. It performed man-in-the-middle attack against those machines. In their report, if you'll read it, they are talking about a process called audio-DG that the malware opens, and then it uses it to host a tool of Nearsoft called NetResView. We can see this behavior right now. This is IronGate. And yeah, you can see this audio-DG. Well, it's in purple, of course, but it's audio-DG behind the purple thing here. And then it terminates. This is the normal behavior of the malware. If we'll look in the process monitor, we'll be able to see that it actually seeks traces of VMware. Over here, you can see how it checks for VM mouse, VMware registry key, and VMAGFS, hostguest file system. Well, that's pretty simple. Let's execute some more malware before we vaccinate our machine. For example, this sample of Loki. It has this random icon to avoid detection. You can see this one is quite old, but it's still doing the trick. It won't encrypt because its CNC sample is, its CNC server is down already, but we'll be able to see how it hollows another process in a moment, and you'll be able to see the difference in its behavior in the next part of the demo. And here in the process monitor, it takes just one more minute, and yeah, you can see how it created this SVC host. We'll terminate it because we don't want to revert the snapshot, but this was the hollowed SVC host that it used. And if we'll look closely enough, yeah. Page up. Yeah, of course. Now I need to go up more. And there we go. So it actually checks for ESET and Avast, as you can see over here. It doesn't find those right now. Oh, I'll just do it this way. So yeah, it doesn't find them. This time it's looking for Kaspersky somewhere up there. Yeah, it's the first registry key over there. We'll be able to see its behavior when it does find one of those registry keys. Next, what we're going to detonate now. It actually deleted itself, so we will need to revert the snapshot. We have this nice Tesla crypt here. It's actually quite interesting because this is a great example of why vaccination is so powerful, because let's delete the trace. this sample of Tesla crypt is actually looking as well for ESET. So we can vaccinate once or twice or 3 times, but it's not like antivirus updates that we need to do every couple of minutes. We can just create those registry keys and files and prevent malware for eternity. It actually sleeps, and then it's creating this random-looking executable that will kill as well. Let's see this again in process monitor. Actually, it's already there. You can see how it doesn't find the ESET, and then immediately it is starting to do some more nasty stuff. Mostly just creating the next phase of the attack. So I have another sample here. It has the same behavior, but let's just revert now to snapshot and re-execute the samples. After I vaccinate, the vaccination script, I'll show it to you now. It's actually, I think it's less than 100 lines of Python. It's the dead simple Python script that any one of you could have been writing. Just create files and registry keys. I didn't create the dynamic kind of artifacts, but I have another script for dynamic artifacts in the GitHub repository. Well, feel free to try both of them. You can actually feel free to contact me if you know any other stuff that are not there. Maybe I can tell you some other stuff that you're not fully aware of. If you're curious about this kind of malware repelling, just talk to me later on. So now our machine is reverted. No, not shut down. Let's close the magnifying thing and reopen those fellas. Let's first execute the Python script, which it's here. Yeah. So, short look, because I'm seeing I'm short on time. You can see it's really simple. Can you see it on the screen? Yeah, it's actually better than on my screen. It's really, really simple script. Just create those files and folders, a couple of registry keys, and 140 lines of Python. And let's activate process monitor and execute the vaccinating script, which is quite simple. You can see, yeah, we're done. We're vaccinated. Now let's prevent the detonation of some APTs. Process monitor is on. Let's do it in the same way that we did it last time. We'll begin with IronGate. You can see that now it won't open this audio DG weird process. It will just have its child process. It is because it is a compiled Python script. It's just its normal behavior. No audio DG. Yay, we prevented some kind of a Stuxnet. Yeah. I don't need applause. I think that it's all for VMware. You can see how just immediately after it finds this registry key and vmouse, its next instruction is thread exit and process exit, and as simple as that. It's the nested Python process, so it will exit once again here, but yeah, it doesn't matter. Let's have another one. Let's try the Loki. Remember that previously it lagged a bit, and yeah, so, sorry. Here you can see how it just terminates in terminates in a couple of seconds. Let's take a look in the process monitor. Again, we'll go for ESET. You can see that immediately after it finds ESET, it just exits, and there, the sample is terminating. We can have another look with other kind of malware, but it all look the same. This Tesla crypt, for example, again. Here, it actually sleeps for about 10 to 15 seconds, but it will actually terminate before it drops this next random executable. And this will maybe create some suspense, but it will terminate in a couple of seconds. Again, for the same registry key, which can be easily created by anyone. Do it at your own responsibility. There are some stuff that can be, here you can see, it just terminated, no random process. Again, in process monitor, this is Loki still, but here, same registry key, again, terminating. And stuff could be broken by vaccination. We should do it very, very carefully. It is kind of my day job to check how we can do this without breaking other stuff. So just take great care when doing this kind of vaccination, and don't add Russian keyboards to your machines unless you're feeling risky today. I think that we'll save the last 4 and we'll go straight to the Q&A phase, right? Q&A phase. So let's,
While he's getting ready for Q&A, I'd like to tell you a little anecdote. Back in 1992, this is 24 years ago, I was in high school, and our computer network got infected. And since I was the geek that was reverse engineering, I found a virus. And the virus was the Haifa virus. That was one of the first ones to employ polymorphic code. It was really fascinating. By the way, 20 years later, I learned that it was a friend of mine who wrote it. That aside, it turned out that the malware creator, or virus when it was called back then, in order to protect itself from infecting himself, made a simple test. If the volume label of drive C was AT_286, it wouldn't infect. So it's pretty much the same. You look for signatures that scare you or something that prevents you from operating, and it just shows you how 25 years can pass and they're still using the same tricks.
So let's go to the question phase. Yeah.
Awesome lecture. 2 questions.
Okay.
The first, have any of your artifacts caused reaction from other security systems, such as antiviruses, or because some of the things you're doing is creating fake DLLs or things like that, which could be
It
caught
can cause damage. That's why
not
it is.
damage, but just a race condition
Yeah.
between you and an agent.
Yeah, it can create all sort of weird effects on your machine. That's why it is only a POC to use on your virtual machines and not on your daily PC. It can be done without interfering other stuff in the machine, but again, this is my day job, so it's kind of complicated, and you can ask me later how it can be done.
Okay, so the
Second question.
you mentioned 4 different ways of deterring attackers.
Yeah.
But there's a logical flaw in that, and that is that I don't think any attacker would expect to see all 4
Yeah.
on the same machine. So if they ran a check that would be slightly more sophisticated, that is to say, for example, it's not logical for it to be a virtualized environment and also to previously be infected. A mutex and a virtualized environment, it does not make any sense, right? So how do you circumvent that?
Actually, there's a great answer to this.
We don't have the time.
We don't have
No. There's actually a great answer and short answer. Let's execute the same script on my analysis machine. And then I win again, because he can't know. Let's execute it on my sandbox. Who cares? It's just a couple of files, so we win again. So, any more questions? most of the sandboxes I know are indeed like even Cuckoo, which is great. I really like Cuckoo. It has some signatures for environmentally aware malware. But it's not perfect. I actually know many artifacts that Cuckoo doesn't have, and the guys behind Cuckoo didn't yet create signatures to, and even if they created signatures, it's not pushed already to the sandbox repository online, and you can do all sort of tricks, but this is actually more from the endpoint view. How can you protect your endpoint against all sort of stuff by just creating this? Did I understand your question correctly? Great. Yeah. It's going to be a great cat and mouse race. So, do we have time for more questions or next? Okay, so.
We have time for whiskey.
Okay.
Let's thank Gal Bitensky, and you can find Gal at Minerva Labs. Well done, well done. Congratulations. Before our